Okay, we're trying to find an expression for this summation, where we're going from r equals 0 up to n. Okay, we've got three, the denominator is factorized into 3, so we're going to split that into the summation of and we're then going to plug the numbers in and hope we get some cancelling, but we'll see. So comparing numerators, left hand side we've got 1, the right hand side I've got to multiply the r plus 1 by these two, so it's a lots of, I've got to multiply the r plus 2 by these two, so I do the same to the top, and similarly c. Right, now we'll let r equal minus 1. I get 1 equals 2a, and therefore a is a half. R equals minus 2. I get 1 is minus b. And finally r equals minus 3, which makes that 0, and just leaves this one. I get 1 is 2c. So I've also got c as a half. Okay, so what I'm looking for then is I'm trying to find, in effect, this summation. I'm going to take the half out. Sorry, I won't. I'll do a half r plus 1, take away 1 over r plus 2, plus a half r plus 3. And we're going from r equals 0 to n. Okay, let's plug numbers in then. I put 0 in, I get a half, take away a half, plus a third. Oh, sorry, this is a half here, isn't it? Apologies. Sixth. Okay, that's r equals 0. I put r equals 1. I get a quarter, minus a third, plus an eighth. R equals 3. R equals 2. I get a sixth. Take away a quarter, plus a tenth. Okay, so now I'm trying to see, well, where's the cancelling occur? This is not immediately obvious. Okay, it looks like half, take away half, but then it doesn't work anywhere else. Remember, we're looking normally for diagonals, and this is an unusual case. We've got this diagonal, that one, that one, that one. Those three cancel. Okay, and if we went next one, we'd have an eighth here, and we'd have more cancelling going on. We'd have this one, and this one. Okay, so they're cancelling on the diagonals, so we're going to be left with these three terms at the beginning, and therefore we need the three terms at the end. So I've got to do r equals n minus 1, and I get half over n, take away 1 over n plus 1, plus a half over n plus 2. R equals n, and I get a half over n plus 1, take away 1 over n plus 2, plus a half over n plus 3. Now I know I'm only left with 3 at the beginning, so I must be left with 3 at the end. These three here. So this these will all cancel. I'll be left with these three terms and those three terms. Okay, so the answer I'm looking for is going to be half, take away a half, plus a quarter from the first three, then plus half over n plus 1, take away 1 over n plus 2, plus a half over n plus 3. Now I need to look at how to simplify that. So I've got so I made a mistake. This is n plus 2 here, so this should be n plus 2. Okay, so half take away half plus a quarter is a quarter. Take away the factor of a half out, because I've got half take away one of these, so it's minus a half effectively. So I get a half of 1 over n plus 3, which is this term, take away 1 over n plus 2. Which equals, now if I write the quarter, I want a common denominator of 4 lots of n plus 1, n plus 3, n plus 2. So here I have n plus 2, n plus 3, effectively over 4, n plus 2, n plus 3. So that's my quarter, in effect, plus I'm going to that, take away that, so n plus 2, so it's minus 2 over 4 n plus 2 n plus 3. Okay, and that will give me n squared plus 5n plus 4. So finally, the solution I'm looking for is n plus 1, n plus 4 over 4, n plus 2, n plus 3.